Hello everyone, we'll be starting shortly. Just wait a few more seconds. Okay, I think we're good to go. We have almost 100 people here today. So welcome everyone. My name is Manuel Colmenares. I work at Pentalogix doing technical support. We have Max Hensi today as well. He's in charge of product development. We're going to be talking about DFM. Just some house rules before we start. There's a Q&A button on top. If you guys if you have any questions, you can write it down. And by the end of the presentation, we'll get to the Q&A and answer as many questions as we can. If we don't get to answer your question, we'll get back to you, even if it's via email or something, but we'll make sure to get to all of your questions after the presentation. Okay, so let's get started. Just 1 second. Okay, so we're going to be talking about DFM, how to prevent delays before the PCB files are released. So what is DFM and why it matters? So when we talk about DFM, we're not talking just about going through a checklist. DFM is about making sure that the board you design can actually be built reliably, repeatedly, and at the cost and time that you expect. It's about getting rid of any uncertainties before the files reach the factory. A board may pass, ERC and electric or a design rule check, electrical rule check in the CAD software, design software you're using, but at the time it gets to the factory, it might have some issues because sometimes designers don't take in consideration some of the rules that the manufacturers use. So for example, you could have a VIA meet the CAD rule for the annular ring that you put, but when it gets to the factory, it was a different number that you had to use. So why is DFM critical for modern designs? So these days we have higher layer counts than ever, smaller geometries, trace widths are shrinking, drill sizes are smaller than ever, and at the same time, production timelines are getting tighter. You may receive the boards and you want to do assembly just a day after that. So you have far less room for interpretation or correction once the design is released from your company to the factory. So we can basically say that DFM has no longer become an option, but it's a risk control mechanism. So traditionally, where does DFM fit in the PCB lifecycle? Traditionally, you have the designer is finished with the design, export the Gerber and Drew files, then gets to the factory, the manufacturer who's going to run the DFM, and then the EQs start going back and forth. You have questions, some violations are found, the engineering team has to make changes, accept changes, back and forth, creating a bunch of delays, and basically it's a cycle that can go over and over again until it's fixed. So what's a ideal better model? We insert DFM before it gets to the factory or the manufacturer. So that's where we want to put SmartDFM in the process. Once the designers finish the design, you can run SmartDFM with the rule checks of the factory or manufacturer you're going to be working with. You can find some violations or stuff you need to go back and fix. And that way you prevent the delays when it gets to the factory. So the cause of poor DFM, basically where the projects breakdowns, let's check some of the common DFM failure points that we get. Start with trace space below the process capability. So during fabrication, the copper is chemically etched away to create the circuit pattern. If the two traces are too close together, The problems that can come up are basically solder bridging. Typically, one of the typical measurements that manufacturers use is going to be a minimum of 4 mil or 0.1 millimeter gap. That ensures that these type of problems won't happen. Again, that's one of the typical problems we have. Then you have insufficient annular ring. I would say probably the one we see the most with assembly shops that we work, and manufacturers specifically. So the annular ring, the little band of copper that you have the copper pad, you have the drill inside. So that little band around the drill, that's the annular ring. What happens is that basically, the drills are mechanical. Factories, they have their own tolerances, maybe drill wandering or different stuff that can happen with the drill process. If the annular ring is way too small for that factory, you can have problems like the drill being out of the copper, creating a breakout. That can be very problematic. Some of the other problems that we have, you have solar mask web thickness. So what is the mask, the solar mask web, the little thin sliver between the two copper pads? So if that's too thin, it can peel away during the lamination, the reflow process. You have then solar molten just flowing around, creating a short between those two pads. Some of the other typical DFM failure points that we have are going to be drill to copper violations, the copper being too close to the edge, or missing board outlines. Let's do one more thing before we go to the next one. It's not even sometimes about it's not bad design, but it's just that sometimes the DRC, the design rule checks, are not checking some of the checks that go on the DFM. So yeah, you may have set up something in your design software, but then you needed to do a change because manufacturer have a different one. Let's take a look at a realistic delay scenario where you have a 6 PCB. You're going to be doing mid-volume production, 500, 1,000 boards maybe, and assembly is scheduled the same week as the fabrication is complete. So you're going to be getting the boards on Tuesday, assembly is set to start Wednesday or Thursday, and then the factory identifies different problems violations. You have 8 annular ring violations, 3 drill to copper issues, 5 solar mask web problems. Then these notes, EQs, are going to go back to the company. Engineers have to decide if some of them are, they won't care about, let's say some of those were seal screen. Maybe they don't want to change something about that, but some annular rings may be a breakout. If the distance is way too small, maybe they can just skip it, but ideally they're going to be going back and forth, changing files, reviewing back and forth. You have a 2 to 3 day engineering review delay, then new revisions required. You miss the assembly, the production slot. It ends up being like a 1 or 2 week delay for the final production. So the true cost of late DFM, we can say that engineering rework time, expedited fabrication fees, a schedule slip, assembly rescheduling, reduced production confidence, and internal stakeholder pressure. So what manufacturers actually check? This is what we talk when we talk about DFM. Typical things are going to be, again, minimum trace width and spacing, annular ring, drill to copper clearance, copper to board edge spacing, and the solar mask web width that we just discussed. So the goal is not to redesign the PCB. The goal is to confirm that it can be built reliably within the process window. So what's the underlying principle? DFM is going to be about process capability. The design rules are going to be static. You have the software where you design, and you have your fixed design rules, but every manufacturer is going to have different tolerances, and that can be a difference in 0.1 millimeters or 0.05 millimeters in some of the checks that we just talked about. So the question becomes, how can we apply the same manufacturing style checks earlier in the process? So we can now go and let's just open ViewMate and go through a sample file and do the SmartDFM and show you guys how we can prevent this stuff. Okay. So we're importing the Gerber set. Let's say someone in the company, the designer finished the files, they were exported. We're going to be reviewing this 4-layer board. First thing when we start, usually what I like to do first, go to a layer organizer. And with the layer organizer, you can basically clean out so the software understands what layer is, like you have a paste layer, but if you don't have the software identify those layers, you won't know that when you get to the SmartDFM. So first we run a auto identify. It identifies some of them, but some of them are still not identified. We know that 2 and 3, the inner layers, we have plated drills, non-plated drills.
You need the board outline.
The board outline. I think we're good to go, right? And then we click on organize. So now the software is basically organizing based on the layer we told it has and the best way. So we have the map layer colors. It's going to help us with the contrast when we want to compare some layers later in the process. We also have the layer visibility here if we just wanted to see like the top layers or just the bottom layers. Very useful tool, the layer organizer. But yeah, once we have the layers organized, we can go directly to the SmartDFM. Okay, so this is SmartDFM window. We start by, if you have any other rule set, you can use a different rule set. And you can actually save different rule sets if you're working with different manufacturers. You may want to have one measurement for the minimum trace width with some manufacturer, but a different one with another one. You can change and save these rule sets and load it at the beginning of once you're going to start running the SmartDFM.
Manuel,
Yeah, go ahead.
if I can interrupt you quickly, that is actually not where you save the DFM rule sets. That's actually called a DFA rule set, and that will save your setup, like how many layers and whether top or bottom and so forth. So your actual DFM rules sets, if you want to use different ones, get set later when we actually start the DFM process.
Right, by the rule, by the checklist window.
Okay. Yep.
That was my bad. So basic setup. You come from here, it's a 4-layer board. We have silk screen. So we have top silk screen, top only. We have top and bottom solar mask. On top paste, we do have plated and unplated holes. Go to the next window. Drill stack up. If we had any BS, blind BS, buried BS, we would care about this. We're gonna just skip here. We get to identify layers. Since we already use the identify layers out the layer organizer before, it's gonna be just a quick identify layers. We go to the next step. If you had any negative layers, you can just change it here. In this case, everything is just as it is. It's going to verify that the board outlines, you have an individual layer for the outline and that it's a continuous line, it's not broken or something like that. Then we're going to get to the clipping section here. If there's anything outside of the of the outline. It's going to let us know. In this case, in the top seal screen, it found some elements out of the outline. So we have 26 elements outside of the board outline. Should we just delete them? Let's say yes. To the next screen, and this is the most important screen. This is actually where what I was talking before about selecting the DFM rule checks happens. If you have different rule sets, you can switch here between the ones you have saved and stuff. We have all these different rule checks here, and we're just gonna go with the default, which is the Pentalogix US Quick Turn PCB specs. So you can see here, we're gonna be checking minimum feature size, minimum space, annular ring for the outer and inner layers, drill hole, seal screen, solder mask. And I want to take this moment just so everyone understands, and the whole point of the DFM is not to find errors and fix them in ViewMate. It's actually to prevent that from happening. You ideally want to run a board, do the DFM, and it will show 0. That means that the design is being done properly. When you find errors, of course, you can just go ahead here and then fix that. But the important thing that you should take out of this is that, okay, so we have these errors. We should go back to the designing software and fix the rules that we're doing there, so that next time you run the board, you don't get any errors. So the actual nice result to have when you're doing SmartDFM is to have a 0 on everything, and that's the ideal result you want to have. When it's running, you will see here this little square rectangular thing here. It's going to be showing the DFM rules running at the moment. So it's almost done now. It's doing the seal screen minimum feature, and there you go. So the error count basically found 32 errors for the annular ring measurement in the inner layers, 7 clearance for the seal screen, 32 for the minimum feature size on the seal screen. So we can click on show, and actually, yeah,
I recommend you set your layer colors.
Yeah,
again, this is something that should get fixed in ViewMate, that it should automatically set the layer colors properly. But
and this is the same thing we did before. Just we run the map layer colors, so the contrast is nicer when we look at the errors. So now we can click on show, and it's gonna go straight here and show us. So we're looking at the first error it found for the annular ring. So the DFM rule specification in this case was 6 mil. It found that the actual annular ring, this space here, has a 0.095 error. So, and again, this is a type of error when we analyze after going on the software, we're gonna check the 3 different types of results we can get from SmartDFM. When the engineers check on this, they might say, okay, 0.095, something we can live with. Let's just leave it like that. Or maybe they just want to go back and do the whole thing and fix the 32. If we can click on next, we can see that it's going to be these 32 paths that have the same problem over and over.
And by the way, just to says, this is a design that I actually did in Altium Designer, and I spec'd a 6 mil minimum annular ring, and this is what Altium Designer created. So sometimes in your CAD system, even if you set up the appropriate rules, they don't always do everything just right. You sometimes see openings in polygon pores where they're not supposed to be. And so SmartDFM is just a good way to catch things that maybe the CAD system didn't do correctly, or more often than not, the problem is that you haven't set up your design rules appropriately in your CAD software. So SmartDFM, it's really 2 things that we're trying to accomplish here. First, we want to make sure your board can be manufactured. and that there aren't going to be any questions when you place it into the manufacturing cycle. But secondly, and I think equally or almost more important, is use it as a tool to find out what you're setting up incorrectly on your CAD system.
Yes.
So if you find repeatedly, after running 3-4 jobs, you're always getting these sorts of errors, go back to the CAD system, set your annular ring to 6.5 mils, or 6.2 mils or 6.1 mils, whatever. It's you never know exactly what you're going to get out of the CAD system, and the CAD system typically does design rule checking, electrical design rule checking. They're not all as good at doing the CAM DFM file checking. Anyway, sorry to interrupt, man. I'll continue.
Not at all. Not at all. Okay, so checking some of the results, we also had the silk screen clearance problem. Let's take a look. Okay, and this is actually something that was already fixed. The silk screen goes over a pad. It was already clipped. So these seven here, this was actually fixed by the software when we selected clip on the previous section. And we can.
Yeah. So actually, for silk screen type errors like this, the previous thing that Manuel was talking about, that was for silk screen outside of the board area. Yeah. But here we're checking for silk screen over holes. So this initial design had that silk screen trace going all the way over that hole. So SmartDFM for things like that, because clipping silk screen is not going to, in most cases, affect your design. So we actually will automatically clip the silk screen to the DFM rule parameter that you've set. So in this case, it's a 2 mil clip. This is useful because oftentimes, you have silk screen that is going over holes and pads and stuff, and it's a real pain in the butt to fix this on the CAD side. Some CAD systems do it well, others don't. So we just do it automatically. And now reviewing them here, this is primarily for informational purposes, so you can see, okay, where did we modify your silk screen? So in cases like this, you're not going to care. But what if it modified your silk screen because you put in the part number on the board, but you made it with 2 mil wide lines? Then all that is going to disappear. So by reviewing these errors here, you can see where we made changes. And most of the time, you can just ignore these.
Yeah. The other thing that it found here, some errors with the minimum feature size, again, for the silk screen. And similar to what Max was saying, some of these are not going to be a problem, like in terms of the board itself, it's going to run just fine, but you may just have it looking not as pretty, if the silk screen doesn't come out as you're expecting. If you want to fix this error, the little line in the 9, it's just too thin. It will not come out perfectly as you were expecting. But yeah, this is not a problem that when we check the three type of results here, we're going to see that this is not one of the main problems that you want to be looking at. But yeah, to finish up here on the software side, again, you can modify the specifications here. And we're talking about, we're using VMware Professional. I read some of you on the chat asking if we can make checks with rules different from the Pentalogix US Quick Turn PCBs. And yes, we can, but it would have to be either on VMware Essentials or VMware Professional, where you can edit the specifications here, save a rule set, and run it over and over again. That's for that question. So someone asked on the chat, I was just reading. And we just, you can have as many rule sets here for many factories that you work with, and check for, let's say you have a board, you want to make sure which factory will this work with. You can load one factory, run it, then check with a different factory. And once you have one that shows no errors, then you can go with that factory from the ones you've used before, for example. Once we finish the SmartDFM, we can extract the netlist. Many people also ask about the netlist extraction from ViewMate. What is this useful for? Ideally, let's say you load the Gerbers, and when you're starting, you want to extract the netlist there. If you make any modifications after that, you want to then extract a new netlist and compare both of them and see if anything changed in connectivity. That's going to be very useful for many people. And once everything's been set up, the errors, you have the ViewMate Professional, you can go ahead and do other stuff like pick and place files, finalize PCB. But yeah, that's basically how SmartDFM is going to work and run. We can go then to interpreting SmartDFM results. So basically we say prioritize, don't panic. Not all DFM violations are equal. So as we were talking before, some of the violations are going to be high risk. When you have copper too close to each other, something that can create a short, those are high risk problems that you definitely need to work on. And again, as Max said just before, the idea is to find these errors and to fix it on your design software so it won't happen again. Because yeah, you can easily just, we have the tools on ViewMate so you can enlarge some pads or fix what you just found. But if the errors keep coming from the designer, it's not making, I mean, the whole point is to save time and prevent delay. So you want to go back to the design part of the process and fix that over there. Then you have conditional errors, the ones you review and confirm. For example, we were talking about a number that is 0.0001 mil error. You might want to just skip that. You don't have to make a change if something's that small. Again, if tight trace is near the limits via verification, and then we have the informational. And I would say the silk screen problems are on what we could qualify as informational, just nothing that will affect the functionality of the board itself, but just the looks of the actual silk screen. Okay, so before we jump to the last board, yeah, before we go there, I think that we can now start checking the Q&A section, and Max and I can start answering some of these questions. Let me check here. So we have the chat. Some people are writing in the chat, some people are in the Q&A section. Let me take a look. Oh, Max already answered this on the chat. Q&A. And Max, I don't know if you see anything here that you want to directly ask. I mean, answer, sorry.
I see something here from Torje. I'm sorry if I'm mispronouncing your name. He asks, many high-end CAD tools have very advanced design rule sets and DRCs these days, which go far into the realm of DFM. What are the practical benefits of doing these checks in Pentalogix in addition to doing them in the CAD tool? As an example, the 6 mil annular ring problem, that design was done in Altium. Altium is, I don't know, I would consider it one of the most high-end software programs out there. It still occasionally makes mistakes. I sometimes see things in polygon pours, for example, where it will be pouring polygons around pads and traces, if I'm, say, pouring a ground plane on an external layer, and it won't pour between areas where it actually should pour. You know, if I have a 10 mil clearance between my polygon and adjacent features, sometimes if it's a 10.01 gap, it doesn't pour through there. Now I have an open. in that polygon. Okay, it's probably not the end of the world, but it may be if you're relying on that poured through copper plane to make a connection to a via, for example. So the truth of the matter is that CAD systems have gotten better and better over the years. I started, with these projects over 40 years ago, and we used to have really extensive problems with CAD systems generating their Gerber data. It's gotten much, much better, and for the most part, you're in good shape. But it's a short check to run. It doesn't take you that long. It's kind of an added bit of confidence that yes, my design has passed a DFM check by a third-party tool that is not associated with my design tool. And I really think that the big thing that you want to take away from this is that running SmartDFM helps you find issues, not necessarily with your CAD design software. The CAD design software might be fine, but it could be how you're setting up their rules there. You can say, oh, I've got, 10,000 nets to run on the top layer. If I just make all my traces 1 mil and the space 1 mil, I can fit it all, And I've heard this before from people, and I've seen some people try to do that. And then they realize they've just designed something that nobody in the world can make. So yes, high-end CAD systems are getting much better. I think it's worth running a SmartDFM check on your boards just to get a little bit of added confidence that you're in good shape. I do it on all of the designs that I do, and I've done, I don't know, well over 1,000 designs in my career.
Yeah, and I think that we can reinforce the idea that it's always good to double check on stuff. You might have something set up one way, but it's always good to go on a third party or second software to just make sure that everything you set up is working just as expected.
We have another question here from Triada. Would you be able to show what other options do we have other than US QuickTurn? Anything particular to higher layer count and HDI boards? Currently, our SmartDFM rules are the rules that you saw in the US QuickTurn flow. So these are the basic rules that are going to determine whether your boards are manufacturable or not. Now, in terms of setting up custom rules, these can be done primarily just by modifying the values that are in the text boxes for each rule. So you can't set up additional rules. You can skip rules if you don't want to check them, but essentially you can go into each one of those text boxes and change your rules. So let's say that you have designs where you want the lowest possible board cost. You want 10 mil trace, 10 mil space, 12 mil copper drill pads, or drill holes rather, and so forth. Set up a rule for that and give it a name, and if you're designing a board that's kind of a punch and crunch board and you want to get it out there and have it built at the lowest possible cost, then check that. Now, if you have a board that has BGAs and you need tighter spacing, you need 3 mil trace and space, set up a DFM rule set for that. And, it doesn't have to necessarily align with a particular PCB manufacturer. You can just set up different rule sets for different technology types of boards and then run them through there. And so if you know that, hey, this board shop that I like over here, they can do 3 mil trace and space, but they charge me twice as much as the guys that do, the punch and crunch boards. So it's just, you can set up the rule sets however you want. However, we're not talking about adding additional rules. If you have rules that that you need checked that are not in our existing rule set, please let us know, and we'll take a look at adding those in the future.
Good. Yeah, so we have a couple more questions here. Can end user from Pedro Martinez. He was asking about if we can edit and modify the rule set using the SmartDFM model. Okay, this is just what Max was saying. I just showed here how you can basically change any spec here and save it as we made this sample low-cost rule set, and you can go back and forth between different rule sets that you say. So yeah, Max, this question, I don't know if you can help me with it. Can you check for copper balancing across layers and overall design?
The DFM rule checks do not check for that automatically. With ViewMate Professional, you can do that by doing copper area calculation. There are copper area calculation tools. But no, that's not something that we currently have in our DFM design flow. But thanks for that question. We will consider it in the future.
Okay, someone else asked if we can get a recording of the lecture. Yeah, this is being recorded and this will be shared after we finish the session. And after a few days, we'll even have it on the YouTube channel. Many people want to get more information about, like, we get emails about people asking for the new PCB navigator for SmartDFM. We do have a YouTube channel. Many people, that everyone can go to and see videos of how it works. If you have more questions, you can always contact us. Let me see if I have any other questions that I see here. Is this DFM tool available in version 11, 24, 15, or only on newer versions? So this DFM version that I just run is going to be on any ViewMate Essential or ViewMate Professional versions. Correct me if I'm wrong. I'm pretty sure that this is the same SmartDFM we've had since we released ViewMate Essentials and Professional recently. Okay. So Max, we have someone asking, can ViewMate run DFM validation using rule sets defined according to IPC class 1, 2, and 3 requirements? And can those rules be automated with reusable templates and reporting? I think we already answered that, right?
We don't specifically test against IPC rules. You could set up the rules to
exactly,
to do that. But one thing that you do have in ViewMate Professional is you have the ability to do scripting and automation using ActiveX automation. So this is typically something where you're going to need a software person on staff, or you can contact us and we can help you do it. But anything that you can do in ViewMate Professional manually, you can do in an automated fashion by running and developing scripts. So for example, if you look at what we currently do in SmartDFM, that is done largely through just scripting. So SmartDFM was created using Visual Basic.net to create the user interface. And then you do something called Dimension Cam as a cam tool. And now you can call up all of the automated commands to make the software do whatever you want. So all of those DFM checks that we run, they are all being done by just manipulating existing capabilities within ViewMate Professional or ViewMate Essentials.
Okay. Any other questions? Someone asked, can you provide learning resource with examples with some Pentalogix software? Let me give you the link for the YouTube channel. Here you can have that. See what other questions we have. Would you say that these rules are for single stage lamination? And do you think they stand relevant? And in a sense, the software checks on multi-stage lamination process. For example, it will check across each layer or just the top and bottom layers.
I don't exactly understand the question. When we have a multi-layer board, then we do inner layer checks, but I don't really understand the question. And unless you're talking about, as the board gets fabricated and it's kind of a sandwich, it's not all being done at once. Can it be done independently? I would say no. We look at a board as an entire board. So we look at it from, kind of top down from, say, top solder paste, top silk screen, then all the way down to bottom solder paste, bottom silk screen, bottom solder paste. It's sort of in that stack. Now, if you do have blind and buried vias, then you can define the connectivity in that screen that Manuel skipped in the beginning, which is sort of a drill layer stack up. But in that menu, you can set up your blind and buried via connectivity. And now when you extract a netlist from the design, it will extract it with those blind and buried vias taken into consideration. But no, we don't do specific DFM rule checks for different stages of lamination. We're really doing it just on the overall PCB to make sure that the board is manufacturable.
Okay. Okay, so I think that we covered most of the questions I see here. Any other questions, you can always send us an email, give us a call. We'll be happy to help you. If anyone has wants to find more information about like licensing or your organization, your companies, we'll be more than happy to help you with that as well. I see okay. Yeah, this is our email, our phone number, our location in Oregon. You can always go to the YouTube channel for more videos, information, our latest news, our latest features, and we'll be preparing more of these webinars to go over different tools that many people still have questions, and we'll be happy to answer them all. Again, you can reach us via email, give us a call. Our sales team will be happy to help. If you have any other comments, we'll be happy to hear, to get feedback on those. And I hope that everyone, yeah, go ahead.
And I was just going to say, if you have any suggestions for future webinars on what you'd like to hear from us, let us know, and we'll take that into account. Manuel briefly mentioned something about the PCB Navigator. This is a relatively new tool. It's something that I'm excited about. It adds intelligence to Gerber data, and it makes it a lot easier to navigate around your design. So we essentially import a bill of materials, we import a pick and place file along with your Gerber data, and now we can tie those three things together. And now you can, for example, say, show me U1, or, go to R2, and it will jump to that component. And if you're having an issue with, let's say you've gotten your board back, you've got a short somewhere, or something's just not working as you expect, it's much easier to navigate the board by, say, clicking on a component in the BOM, and it will show it to you on the Gerber file. So that's something to look forward to. It's probably going to be our next webinar. Not sure exactly when that's going to happen. It depends on how long it takes Manuel to put things together.
Yeah.
But we look forward to seeing you all in the next one, and want to thank you for attending today.
Yeah, thanks everyone. Over 100 people are in this session right now live. So thanks everyone for coming. And again, this is being recorded, and it's going to be live for all the other people who were not able to make it today. So happy to see so many people coming, and you all have a great day, and yeah, enjoy the rest of the day. Bye now.
Bye-bye.